Hi, so in this video I'll be showing off my RF Moggy, which is basically a CC1101 chip controlled with an ESP. In this case it's an ESP8266, and it's easy to build yourself, do it yourself. And I'll explain the reason why I made this. The biggest reason why I made it, the original idea, was I wanted to hack Touchtunes Jukeboxes. I think this is one of the easiest radio hacks out there if you're trying to learn radio hacking. I go to a lot of bars, and there's been instances where bartenders or customers will reach behind the bar and grab the remote and skip a song if they don't like it without asking permission. And I was at one particular bar and they were skipping a lot of my songs because they all preferred country music, but I prefer 80s music. And I decided that I needed revenge. And if you do the research, you'll find in the Touchtunes remote control user manual that the remote operates at 433.92 megahertz. It's actually an ASK signal, not an FSK. And with that information, I brought my RTL SDR to the bar and sniffed the signal when they were skipping songs. And then this was several years ago before Universal Radio Hacker was released, so I would have to use Audacity to reverse engineer the signals. And I had to print it out and do it by pencil. Sometimes I find that's easier. This is a kind of a breakdown of what the signal looks like, and the timing and the characteristics of it. It follows something called NEC infrared protocol. So there's some documentation about how that operates. And there's also this jukebox ID. So if you get into this jukebox hacking, most jukeboxes, if they're in a remote location, they'll keep the default ID as 00. But if there's a bar right next door, they'll usually change the ID so that way they're not sharing the same remotes, And this jukebox ID is actually pretty easy to brute force. It's only 256 combinations. It just takes a few minutes to go through all the combinations. And then upon further research, it turns out that somebody else already did all the decoding for all the commands, and you can find these in the HackRF firmware. And my very first original model, based on the skip song signal, was made with an Arduino and a little cheap 433 megahertz transmitter and a little push button. But I didn't like this design because it was really clunky. I had to attach it via wire to a USB battery, and I have to hold this device in my hand when I press the button, so it's not very discreet. I was usually having to do this outside the bar while I was on my bicycle or something. And then as time went on, I discovered the Texas Instruments CC1101 chipset. This is a transceiver that operates in the ISM band, the industrial science and medical bands. These are the frequency ranges that it can transmit and receive in, and it's very inexpensive. It's about $5 to $20 depending on where you get it, and it's low power also. It's only about 10 decibels, 10 milliwatts, about the same strength as a garage door opener. I had looked into alternative transmitters. I already have a yardstick one, which uses RF but it requires a computer for that. If I was out in the field, I would use a Raspberry Pi. It's a little bit clunky. There's some websites where you can design cases for it, but more importantly, it's expensive. It's about $100 to $150 with the antenna. So I was kind of paranoid about losing it if I carry it with me out in the public, if it's in my backpack. I was also worried about breaking it. And there's also some documentation about pairing the CC1101 with Arduino, and the author called his RF Kitten. The problem with that is that most Arduinos are 5-volt logic, and the CC1101 is a 3.3 volt logic, so you'd have to get a logic converter. And it's also not wireless. So again, you'd need a computer and a monitor or a keyboard or something like that to interact with it. But I want something more discreet than that. And the best solution I came up with is to use an ESP8266 or the Node MCU with the CC1101. You could also use an ESP32 if you like. And it checks off all the things I wanted. The Node MCU is inexpensive. You can usually get them for about $5 in bulk. I'm not afraid of losing or breaking this device because it's altogether it's probably less than $20. Both of them use 3.3 volt logic, so I don't have to have a logic converter. And the ESP8266 has Wi-Fi built into it, so it can create its own Wi-Fi network, and then I can connect to it, and then I can create my own web pages and store them on the ESP and access them via Wi-Fi, and I can use those web pages as menus to control the CC1101. And I can do this all over my smartphone. And then luckily, the same person who drew up the schematic that I use is also the same person, Little Satan, who wrote this library for the CC1101. So everything was downhill from there. I'll go over the hardware as far as building this if you want to build your own. There's no soldering needed. So most of the chipsets you can buy, the ESP and the CC1101, already have the pins already soldered onto them. And everything is available on Amazon. So here's a Node MCU. And then you can usually find the CC1101s. They're easy to find on eBay for cheaper prices. It looks like here's one where you can get 2 of them for about 22 bucks, so it's $11 each. And then you need a few other accessories if you want to build it like I did, where you need the breadboard, you need your wires, and your wire strippers. And more importantly, you need a dual row receptacle adapter for breadboards. It's easy to find 8-pin ones for like ESP826601s and things like that. Finding 10-pin adapters is a little bit harder. The only place I found that sold them was this Technological Arts website. And if you message them before you order, they can ship them to you. They originally shipped soldered like this, but if you message the seller beforehand, they'll ship them out unsoldered, so that way you can solder the CC1101 directly onto the PCB like this for a tighter fit. And then optionally you can add a case to it. Here you see why you need the receptacle, because there's this gap in the breadboard. You need this receptacle so that the chip can fit and be separated for this gap right here. And then depending on whether you soldered it directly to the PCB or use the pre-soldered with the plastic right there, would depend on what case size you get. I had to, if you use a larger case, I had to nibble out a little bit of plastic right here so the antenna would fit. So I used a nibbler. You could probably use a nail file or something like that to chisel this away. And then the really cool thing about it also is that you can just power it with a 5-volt USB battery. You can get these batteries at a lot of gas stations and things. And then once it's powered up, you just throw it in a backpack or a fanny pack. It will broadcast its own Wi-Fi network, and you connect to it with your smartphone and then access the menus with your smartphone. So it looks like you're just sitting at the bar or standing out in public, just playing on your smartphone, when in actuality you're controlling this device and sending out radio signals. So I go over the code a little bit now. So there's 2 options if you decide to use this. There's the client mode, where it will connect to your home Wi-Fi, and then you can just access it via your LAN. And then when you boot it up, you'll have the Arduino serial monitor up, and it will show you what the IP address is, and you put the IP address in your web address, and that's how you access the menus. The other option, if you're out in the field, is you put it into host mode, and it will broadcast a Wi-Fi network called RF Moggy, and the password is do-it-yourself Moggy, DIY Moggy, and you connect to it that way, and then you just visit this site 192.168.1.1, and that will give you access to the menus. So depending on what you want to use, you have to either comment, uncomment the two sections. And this is a general idea of what the menus look like. And if you know the basics of HTML, it's mostly all HTML, which is a little pinch of CSS. It's easy to edit and add and delete your own menus if you understand how the CC1101 chipset works. And that's kind of where I came up with the name Moggy. If you don't know what a Moggy is, it is because the yardstick one is uses RF cat, and then there's RF kitten. I called mine RF Moggy because a Moggy cat is actually it's like a mutt. It's a non-pedigree cat. It's just its own little thing. So I'm hoping that once people understand the hardware concept, they'll come up with their own versions of what to do with the CC1101 and an ESP controller. So I hope to see a lot of different variations of this, other protocols added in, things like that. So, and then this is an idea of what I programmed into it. I got the Touchtunes Jukebox remote cloned into this. And then I also have the old school garage doors that use dip switches. I've got a brute forcer, and then also the DeBrujin sequence hacker, RfPwnOn menu, and then there's also a jammer in there too. So, and pretty much all those menu options there will call a function called binary brute send in the code, and I modeled this function off of the RfPwnOn program and its command line options. So if you understand RfPwnOn, you'll understand this function and the options that it needs. And if you know anything about old school garage doors, they can do 1 zeros, but they also can do trinary bits. So my device doesn't do trinary bits yet. And then if I had to write this code all over again, I'd simplify it in some areas. I wrote this several years ago, and I'm just not doing the YouTube. But my understanding of the CC1101's improved, so I could cut a lot of the fat out of this code. Before I demo it, I'll show you the code real fast. So here's it's setting up for the Wi-Fi. Here's the DeBrujin sequences. If you don't know anything about DeBrujin sequences, basically, so like if there was a garage door with a 10 switch dip, every combination of 10 that you can think of will be in this string. It's almost like a word search. So any dip combination you can think of in a 10 switch dip will be in this big long string, which is pretty long. Other programs like RfPwnOn, they have their own little generator that does this, but I just went online and did the strings myself because I was too lazy to write a generator. And then here's the commands for the jukebox. So like here's the command for skip song, volume up, volume down. You can power off the jukebox. And then this just handles some of the online menus. And then here's where I'm calling the binary brute send. So these are for the jukeboxes, where this is the pulse width modulation for 1s and 0s, the frequency, the baud, and then how many times to repeat the signal, the gaps in between those repeats, and how long to wait between a brute force attempt, and a few other options that I won't go into. And here's for the garage door dip switches. As you can see, I reverse engineered the protocols for things like linear garage doors, Chamberlain's, and Stanley. And then here's the DeBrujin section, again with the Stanley, linear garage, Chamberlain. And then the RfPwnOn menu. the jammer menu, and then here's the function for the binary brute send, which is just a lot of conversions as far as converting the simple binary to the pulse width modulated binary, which I won't explain. And then so that's the bulk of the code, some functions that help with that conversion, and then here's my setup where I configure the CC1101. If you do build this, you have to, it's suggested to calibrate the chip, and so there's an explanation about that right here. So for the particular chip that I just showed, it's calibrated to this, and I've made this for a few other people, and here's like the calibrations for those chips. Here's setting up the Wi-Fi, and then you would have to comment out this if you want to run it in client mode, and uncomment this to run it in host mode. So hopefully you have an understanding of Arduino coding, the basics, so that you'd understand where to uncomment and comment if you want to switch between client mode and host mode. And then here's the HTML menus. So if you just know basic HTML, you can kind of edit the menus yourself. And so as far as I'll demonstrate this in action, I'll do the DeBrujin sequence first. So supposedly the DeBrujin can transmit all the dip combinations in one single signal. You don't need any brute forcing. This was made popular by Sammy Kamkar, and he used this little kid's toy to do it. I personally have never found a garage door susceptible to this. I really haven't tried, but it's usually garage doors that are older than 30 years old. So, and if you've never seen dip switches before, this is what they're like. So you have to make sure that these switches, the numbers that are on and off, match on the receiver. They're dip switches, and it's as simple as that. It's a very insecure radio protocol. And what I'll do is bring up my menu, GQRX. I'll plug in my Moggy. And there's it will display the IP address. I have it in client mode right now. So I'll do the linear because it's a long signal. I'll have it repeat 3 times just so you can get an idea of the sound and everything. So supposedly if the garage door is susceptible, it would be opening right now. And now I'll demonstrate the brute forcer, which will iterate through every possible dip switch combination. I've only tested this on the linear models because it's easy to find these linear receivers online. I think I got mine for about $30 off Amazon. And then I used a universal garage door remote to reverse engineer these garage door protocols. Here's the instruction, the sheet that comes with the garage doors that you can handle with one of these things. So for a linear, it's 10 dip switches, so there'd be 1,024 combinations I have to go through. So here's the receiver, and if you can tell, I have the number 6 and number 10 switches turned on. And it's the same thing on the remote. I have the number 6 and the number 10 dips right here turned on, so that it should And if you listen, you'll hear the receiver, the switch in there click when it gets the right signal. So if you can hear that clicking noise coming from here, that means it got the garage door signal. And so we're going to try to brute force it with DeBrujin. I'll actually turn the volume down so you can hear the click. I'll bring up this menu. And it should take a few, I set the dips so that way it will find the right combination in the first, I think, like 10 seconds. So here we go. There it went. I disconnected it. And as you can see, here's the signal right here. So that's where it clicked at. So I was able to successfully brute force it. And if I were to go through all the combinations, I think I timed out where it would take no longer than 12 minutes to do something like this. Then I'll plug the Moggy back in. I've got a lot of devices plugged into this USB port, so I think it's finicky with oh, I know it's doing it. The USB ports are kind of competing with each other. Okay, it's back online now. And then I will demonstrate the jammer real fast. Jammer. We'll set it to 433.92. I'll set this to 433.92. In case I wanted to jam the jukebox remote. And we will do amplitude shift modulation. And I will jam for, I'll just do 10 seconds. I'll turn the volume up. And here we go. Oh, that's somebody's temperature sensor probably. I think it's mine. Let's get jamming. So it's crashing right now because it works. I just need to add a yield in here before. So I'll have the code fixed before I put this on the GitHub. But that's how the jammer works. It's pretty simple. People shouldn't be jamming anyway, so it's not that big of a deal. And then I'll demo the jukebox after these next few slides because I have to do that from a bar and film that video separately. Just a side note, this device is kind of similar to some few other ones that are on the market. There's the PwnOn RF, which is a lot more features. It transmits and receives. It's very expensive. It's over $500 for one of the simpler models. But when you buy it, you get access to the Kaiju server, which is this huge database of pre-saved radio signals, and they also have options for like decoding rolling codes and things like that. There's a lot of features, so you have to look it up. And there's also the Evil Crow RF, which has two CC1101s built into it, so it can transmit and receive at the same time. It's fairly inexpensive. It's less than $100, and it has the potential to do something called a roll jam attack, which is something else that was popularized by Sammy Camcar. But I think from what I've seen in the Discord, it's still in the works. And then finally, there's a big warning about this type of device. This thing's designed for educational and training purposes only. I consider it a red team tool to highlight radio security and to help train, the power of the CC1101 chipset. If you use this outside your household and you get caught by the police with it, you could have legal consequences. It could be considered a burglary tool, and in most U.S. states, that is a felony. And if you're caught using a jamming device, that's an even bigger, that's something that I consider more scarier, because you're talking about federal fines, which will usually be higher than $10,000. And then if you're doing something really nefarious with it, you could face federal prison time. So use caution when using this. And then so now I'll demonstrate using this thing on a jukebox.